Today we're evaluating this cute little integral. I really like this one because it's got e's and x's, and you see we kind of flipped the way that they're shown here. We have e to the x, and then we have x to the e. The thing to keep in mind when we're working with something like this is that e is actually a fixed number. So e doesn't change no matter what. The x is the thing that's changing when we take our integral or look at it as a function. The antiderivative of e to the x is simply e to the x. The antiderivative of x to the e, we are going to, in this case, think of this as the opposite of the power rule in derivatives. We're going to add 1 to our power, and we're going to divide out by our new power, just like we would if e was x squared instead or x cubed. And we are evaluating from 0 to 1. So now we're going to punch those numbers in. We have e to the first plus 1 to the e plus 1 over e plus 1 minus, and now we're going to punch 0 in everywhere we see x's, e to the 0 plus 0 to the e plus 1 over e plus 1. All right, so a couple things to keep in mind here as we're working through this. First of all, 0 to anything, that is going to be equal to 0. E to the 0 is always equal to 1, so we can just punch that in there. Now this number right here, 1 to anything, is always equal to simply 1, so we're going to substitute that. And last but not least, e to the first power, we can just write that as regular old e. So when we put this all together, we are going to have, this is going to give us e plus 1 over e plus 1, and then subtract 1. And there is our nice and beautiful solution. Thank you for listening.